This is our second video for lesson 3.6, 7th grade math, where we are writing expressions. So I'm looking at the second and third page of your assignment, and I'm only going to give you a few examples in here just to kind of get your wheels turning and to maybe help you out if you're feeling a little bit stuck. I do love the directions on this page. Notice it says solve. You may use a diagram, model, or table. This is a gigantic hint to us. So as we look at pages 2 and 3, I really want you to be thinking of, is there a way that I can model this or demonstrate it just to help my understanding? So visually speaking, is there a way that I can show it? I do not know if there's enough space in here for all of us to show our thinking and writing in an organized way. I kind of struggled with that, in fact, in my first video. So that might tell me that maybe line paper would be a good direction for you to move in. Now those rules or those steps that came from the front page, they're still important here. So if that means you need to, jot them down, you need to copy them over, you need to flip back and forth just to double check you're doing these things in order, that would be a great idea. All right, so I'm just going to grab a few of these just to see how things are going for you. Number 11, the length of a picture frame is 8u minus 12. Oops, I should say is the quantity of 8u minus 12 inches. Its width is 3/4 of its length. Express the width of the picture frame in terms of u. All right, well, I know I'm looking for the width, so I might box that in. That's what I'm trying to find. And I'm picturing a picture frame. Well, I don't know if it's really going horizontally or vertically, but they encouraged me to use a diagram, model, or table. So here's my picture frame. I'm modeling it. If the length is the quantity of 8u take away 12, I better label that. And it says its width is 3/4 of its length. Well, that makes sense to me. Here the width would be a little bit shorter, wouldn't it? 3/4 of something isn't the whole thing. So 3/4 of, oh, there's some decoding here. 3/4 of its length. That means 3/4 times its length. I can show that. 3/4 times the group of, or the quantity of, 8u take away 12. All right, I got this. So again, this might be length, this might be width. Maybe I want to label those length, width. Just put W there for width. So express the width of the picture frame in terms of u. Well, that just means I'm going to use u as my variable. It better show up in my algebraic expression. And oh, I found it. It's right here. Here we go. 3/4 times the quantity of 8u take away 12. Awesome. I could label this in some way, shape, or form, but I better not, because I've forgotten something. I found some keywords along the way. The word of was really the #1 key. There were no backwards words in this situation, but there is distribution. Oh, I need to distribute this 3/4 times 8u and then times 12. Well, let's think. I realize that this 4 and this 8u would cross simplify. 4 goes into 8u, or if I split 8u into 4 groups, I get 2u in each. 2u times 3. Oh, and I get 6 u's. If you can't see that just off the top of your head, it is okay off to the side to say, what is 3/4 times 8u over 1? Oh, cross simplify. Maybe then you can see it here, and you'll be heading in the same direction. All right, but I was able to see that, just thinking it through a little bit, taking my time to do that. I encourage you to do the same. Well, next, don't forget, I can take 3/4 of 12. What that means is, if 12 and 4 will cross simplify, 12 is split into 4 groups, I'd get 3. But 3 times 3 then, and that numerator would get me 9. All right, so it looks like I'm going to have 9 at the back. Notice there was subtraction, so in this case there still is subtraction. If you're a person that changed the minus to a plus, change the sign of next. And I don't know if it was necessary on this problem, and that's okay to do, as long as you remember to take it back to a final format. Looks like you'd have an add the opposite or subtraction happening here. Well, these are word problems. You need to give me words back. What are we measuring the width of the picture frame in? We'll go back and find out. If it doesn't say, we can use units, but I think it does say. In fact, in here it says inches. Oh, I want to call this inches. You could give me a really fantabulous sentence, by the way. I wouldn't mind that at all, but in your sentence, I should see the label of inches. Oh, what this looks like it says is 6u take away 9 inches. This is not good. That inches doesn't just go with the 9, it actually goes with the whole quantity. So I'm going to emphasize that you use those parentheses today when we're using our labels. So get me some good labels. I forgot to talk about format. Is this a final answer? Well, that would mean my variables come before constants. They do. That would mean that I have subtraction in place when needed. Well, I do. That would mean that there's no other distribution. Did I talk about ABC order? I think I'm in good shape. This is a final answer. All right, let's take a look at another one. Number 12. If 6 tablespoons are equivalent to 1 fluid ounce, how many fluid ounces are in 10t take away 4 tablespoons? Oh, it says I might want to use a diagram, a model, or a table. So I'm thinking here, I might just grab this important piece. I'm going to translate this a little bit. 6 tablespoons are equivalent, that means equals 1 fluid ounce. So over here, I have 1 fluid ounce equals 6 tablespoons. So this might be kind of a table organization. All right. How many fluid ounces are in this many tablespoons? Oh, how many fluid ounces are in that many tablespoons? So I'm trying to think here if there's a better way to show this to you. Well, if I keep the tablespoons on the same side here, I'm trying to get to a quantity of 10t take away 4 tablespoons. So how would I get there? And the question is how many fluid ounces? Okay, I kind of have a table set up. Well, if I knew what to multiply by, say 1 times something gets me there. I don't exactly know that. So if I'm trying to figure out how many fluid ounces are hidden in there, I probably could highlight or frame or box in what I'm looking for. It says how many fluid ounces. That's the question I'm trying to answer. Wouldn't it be like saying I have this total amount and I'm splitting it into 6 tablespoons each? Oh, I could picture it maybe another way. If this was the quantity of 10t minus 4 tablespoons, I could split it into 6 and 6 and keep on going until I figure out how many 6's fit into that quantity. Oh, another way of showing that would be division. So for this, I'm going to write, I'm taking the quantity of 10t, take away 4, and I'm dividing it entirely by 6. Hey, this isn't bad. In fact, some of you might say, hey, that's great, label it and call it good. But the truth is, you can simplify. So if you take a look here, there are a couple things we can do. When I have this 6 in my denominator, it's kind of like I could break this into 2 pieces. I could write this as 2 terms, and I'm not sure we've seen a lot of this. So if you're not seeing that, another thing we could do is just simplify, divide them. All these numbers seem to simplify or divide by 2. That's a common factor. But I'm going to try this for you. So this is the same as saying 10t is divided by 6, or 10t sixths, and I'm taking away 4 sixths from it. This is another way to show it. In fact, I can split this into 2 separate terms. Both of these things are being divided by 6. It's kind of like when we factor something out, right? So if I were to continue with this idea, let's see here. This is not a final answer because I see I can simplify. In fact, 10 and 6 share a common factor of 2. 2 goes into 10t 5t times, and 2 goes into 6 3 times. And next, I could divide the top and the bottom here by 2 as well. I could get 2/3. Oh, this isn't bad. This is an okay answer. I wouldn't freak out as long as maybe gave it parentheses and called it fluid ounces. We might be able to do better. Could I put that back into 1 term? Maybe you can see it that way also. Maybe you could say, hey, I could divide this whole quantity by 2 on the top and the bottom. That's kind of like factoring something out, right? That's a good idea too. So it would also be the same as 5t take away 2 over 3. I'm not sure that there's a better answer, one over the other. I would say as far as terms, well, this has me down to 1 term, so that's not a bad thought. And again, we have to make sure we label fluid ounces. I like them both. Make sure that they're labeled, make sure you're using your parentheses. So again, I was visualizing I had a big amount of tablespoons. I'm dividing or splitting them into 6 tablespoons each until I can't do that any longer. So that split is really showing me division. All right, maybe the words are in for a clue. Are in. Is that kind of like splitting something up? I didn't think about decoding that a minute ago, but I see it now. All right. With that, I'm sure you're going to run into some other exciting questions in here, but I want to see if we can get a little bit farther and take a look at something on the 3rd page. Now, I know, I hope I didn't skip over, I did, I skipped over a ratio. I'm going to stop here at number 15 then. Number 15 and 16 I think will be good examples of ratio. So you just took a ratio pretest for me. That tells me that you are aware that it's going to be an important or critical piece of your unit of study this year. It won't happen for a while, but having this background that comes from 6th grade math would be a good idea. And you will be tested on it again to see if you're showing growth over time. So if I take number 15, they're talking about the ratio. First of all, let's talk ratio. What is it? Oh, it's a comparison of quantities. Okay, so I might say in this room, maybe there are 12 boys to 11 girls. Or I might be able to say that there are 16 tables to 2 desks, in which case I could simplify that and call it 8 to 1. So it's really comparison, and oftentimes it's written in simplest form. So comparison in simplest form. Won't always be, but oftentimes it is. So in this case, I realize 5 to 7 seems to be a comparison. They're comparing 5 of something to 7 of something. And if I go back, remember there's an order to this. They're comparing the number of pencils. Oh, pencils is first, so the 5 goes with the pencils. To pens. Oh, comparing 2 pens. So pens come second, 7 pens. All right, so kind of translating this a little bit. There are Q pens. Express the number of pens in terms of Q. Well, if you go back up to the top where they talk about the instructions, try a table, try a model, try a diagram. Oh, it's a ratio. I can quickly draw a bar model. So I want pencils. I want to compare pens. And it said that there are 5 units of pencils. Doesn't mean that there are necessarily 5 pencils. There could be, but there could be 10 or 15 or 30 or 300. And pens, I want 7 units. It doesn't mean that there are 7 pens. There could be, of course, but there could be 49 or 700 or 7,000. Just depends. So if I read on, it says there are Q pens. Where does that Q belong? Does that go in each of the little boxes? No, because that would make 7 Qs. There are Q pens all together. This is kind of like a total. Decode and call that the total. So if I were to show that, it would probably go with the whole bar. Oh, I almost wrote a 7 there. Sorry. So instead, let's call that Q. Be careful, your Q probably needs a tail, so we know it's not a 9. It is a variable. Express the number of pencils in terms of Q. Well, I would if I could, right? In fact, I think I have a plan. If I know that this entire bar is Q in length, or Q in total, what would just one of these be worth? Oh, it's like taking this Q and dividing it by 7. Q sevenths, or 1/7 Q. And if that's true for this little box, it's true for this little box, and this little unit, and this little box, and this little unit, and it would continue for even the units up here. So let's talk. What would this whole bar be worth? Isn't it like saying Q sevenths times how many units? 1, 2, 3, 4, 5. Oh, that's right, there were 5 units. Haha, I figured out how many pencils there are. Please don't frame it, please don't circle it, please don't call it a final answer, because we're missing something. Did I find keywords? Well, I talked about ratio, that's a keyword. And I used the word pens to mean the total. I decoded that a little bit. No backwards words in this situation, but there is not any distribution, but there's something to simplify. There's some multiplication here. So this is kind of like saying 5 over 1. I want 5 groups of Q sevenths. Oh, if I were to do that, it looks like I'm going to get 5Q over 7, or 5/7 Q, means the same thing, and I want to call these pencils. Now you might be freaking out on me. You might be saying, Mrs. Schumann, you forgot your parentheses. Well, the truth is, I might not need them. As long as you show this as one term, which I have done. It's a fractional term. Okay, there's no addition or subtraction separating it from a constant or another variable. It looks like this is a final answer. If you want to put parentheses on, it's not wrong, but food for thought, not needed on this one. All right, I see another ratio problem coming at us, and I know that this is kind of a new idea for a lot of us, so I'm going to try to get us there now. Wish me luck. Turn around the other room. And number 16. You are here. Our steps are still important. I'm going to hide them kind of near the top. I'm going to bring this down because it looks like I've been using a lot more space than what I was provided. So again, I hope you're on line paper. I don't have that luxury when I'm trying to show you my thinking here, but you hopefully do. You have something up to show me your thinking, and it's numbered. Number 16, you are here. Okay, let's do some reading and see what we can do with this written expression. How can we translate these words into algebra? When 5 adults joined a group of Y diners. Oh, I'm going to stop right now. Somebody joined the group. 5 of them joined the group. Isn't joining something adding? It's putting things together. That's not on your keywords. You might want to add it. Definitely is true. The ratio of the number of adults to children in the restaurant became 3 to 5. Express the number of children in terms of Y. Well, this is interesting. First, it says when 5 adults joined a group of Y diners. This is kind of like the after, isn't it? the ratio of the number of adults to children in the restaurant became. So this adults goes with the first term of my ratio, the 3. Check. The children goes with the second term of my ratio, 5. Check. Could I draw that? And again, I'm going to kind of maybe do that over here. It's kind of like the after. After something happened, this was true. I had a ratio of adults came first, so I'll just call them the A's, and the children, they're the C's. There was a ratio of 3 to 5. Oh, come on, pen, you can do it. Okay, that's not all bad. I can see that I have a comparison. Trying to keep those boxes about the same size. It's not perfect, but it's pretty close. I have them labeled adults and children. And it said that this happened after 5 adults joined the group. After 5 adults joined the group. So if I were to move backwards in time, 5 adults joined a group of Y diners. If I could go backwards in time, if there were not 5 adults joining, backwards in time, how many adults were there before anybody joined? Oh, they joined a group of Y diners. There were that many, Y of them. Could be 5,000, could be 14, could be 2. I really don't know. But I started out with Y. And when I went this way, kind of thinking as I'm heading this way, I'm adding 2. I'm adding 5. This is how I know it. It says 5 adults joined. So, okay, I first kind of went backwards here. I said, well, how did they start? They started out as Y diners. And I'm adding 5 more diners. Well, now I know the adults are a total of Y plus 5 more. Oh, I got this. So they want to know how many children there are in terms of Y. Using the variable Y. They want me to use some algebra. That's a great hint. You want to remember to keep your variables in there. Don't be dropping them. Well, in order for me to do that, I need to figure out what 1 unit is worth. Well, if this was, say, 15, 15 divided by 3 would put 5 in each box. Let's pretend this was 18. 18 divided into 3 little units would put 6 in each box. Well, this is neither of those. In fact, this is Y plus 5. It's kind of like a total. And what do I want to do to split it into 3 parts? Oh, it's really saying let's divide it. So I want to take Y plus 5 and split it into 3. This is a good start, because if this little Y plus 5 over 3 fits in each of these little units, it also fits into each of these little units. So here, let's answer this question. How many children are there? Well, I know that there's Y plus 5 over 3 in each of these units. And how many units are there? 1, 2, 3, 4, 5. Oh, that's right, there was 5 in my ratio. So I'm taking this times 5. Well, the way I wrote this kind of looks like there's a distribution. It kind of looks a little bit backwards, but it's still true. What I really want to do is take 5 times what's happening here. So I want 5 groups of this. Another way of writing this might be 5 over 1. And I'm going to show multiplication here. This is like saying 5 in my numerator. So 5 is being multiplied times everything up top. If I were to rewrite this, I might write it like this. 5 groups of Y plus 5. All split into 3, all divided by 3. So again, it's kind of like when we're multiplying fractions, we'd multiply the numerators, we'd multiply the denominators. Here we are. Not a final answer because there's distribution still happening. Now this 5 can distribute to everything inside the parentheses using a multiplication. So 5 groups of Y is 5Y, and 5 times 5 is 25. And there was addition in this sum or in the parentheses, so there's still addition. Oops, it's supposed to be an add sign. Okay, addition symbol. And all this is happening over 3. This is not a bad answer. In fact, you just found me how many, what were they? Forgot to box them in. How many children was the question. So, parentheses, we might call these children. Did I need parentheses on this one? Interesting. Oh, looks like I wrote it as 1 term. So for that reason, no, the children would go with all of it, the whole term. With or without the parentheses, this one would be okay. Pretty good final answer. You might want to box it in and frame it. I'm not sure if black is showing up for you, but I hope you can see what I've written here. All right, let's see if we can take one more. I'll move this out of the way a quick minute. Is there anything happening with percent? Because I know that's been a challenge for us also. Yeah, the next one I see with percent is happening here, number 17. So let's take a peek at number 17 before we call this video final. And Let's apply what we've talked about in percent, because I see that there's this 8% coming up. We might need that. All right, let's do some decoding. First thing it says, find those keywords. Freddie paid W dollars for a camera. Oh, that's kind of important, so W dollars. Okay, I can picture that for a camera. 120 for an additional camera lens. Oh, 120 for an additional camera lens. This idea of additional is really telling me it's added on. It's more. It's going to cost more, right? You buy more, spend more. It's like spend big money at Menards. And then it says, if the sales tax is 8%. Oh, let me think about this. 8%. 8% is the same as 8 out of 100. And if I wanted to turn that into a decimal, well, I need the 8 in the hundredths place. Look at this awesome denominator. That's great for decimal land. 8 hundredths. There we go. And this extra 0 in there, it's needed to make sure we get 8 hundredths. Now, I don't know if you've gone shopping before. If they charge you tax, what happens? Oh, you buy more, you spend more, and then they charge you even more with tax. Welcome to the American way, right? So we're going to have to pay more. This 8% is kind of added on. So when it says tax, I'm thinking somehow it's added on. All right, this is interesting. So how much did Freddie pay for the camera and lens, including the sales tax? Oh, so they're adding everything together. How much did he pay? Oh, Freddie, oops, I don't know if I need Freddie there, but how much did he pay? And they're talking about all together. The camera lens, the camera, and the tax. You can't just go into a store and say, oh, here's your money for the camera and lens. If you don't have money for the tax, you don't get to go. You don't get to buy those things. So number 17 on your line paper, let's see if we can do some decoding. It looks like I want to show you what Freddie's buying. So if I were to use a model, I could say, I know he bought a camera. How much did that camera cost? Well, go back to the beginning. Oh, he paid W dollars. W. But then don't forget, he bought a lens. Okay. And the lens, well, it says it was $120. We don't know if that's more or less than the camera. I don't know much about cameras to know which that would be, but it doesn't matter. We're just drawing a model to make this work at this point. So $120 for the lens. Next it says that there's 8% sales tax. Oh, it's like a tiny piece of this entire thing. So if I were to combine these for a quick minute, how much would these two things cost together? It's kind of like saying, well, I'd have this W and this 120 more. The whole purchase looks like it would be $120 before tax. But I said before tax. Think about this. When there's tax, they're adding on more. They're charging you 8%. 8% of. 8% of the total. Oh, I'm using the word of, aren't I? 8% of tells me I'm going to do some multiplication here in a second. 8% of the total. So just kind of thinking through what percent means and maybe trying to decode in my model a little bit. So I'm going to add a little bit more on. These dotted lines are like, hey, by the way, there's going to be a little bit more here. So this is going to be 8%, maybe written as a decimal. So let's talk about what that could look like. We did that up above. We showed it as 8 hundredths. And it's not just plus 8%. It's 8% of something. We need to multiply times the total. Oh, why did I write 120 up there? That wasn't very smart. If I look back at my model, I hope you caught it. I hope you caught it before I did. Notice this whole bar, it's not just the lens, silly me, it's actually the camera too. So it looks to me like it's W plus 120. All right, so I need to take 8% of that entire thing, don't I? 8% of the W, the camera, plus the 120. Ah, that would be how much tax I'm going to add on. So this is a great start. I think we could go ahead and use our model at this point and say, all right, camera plus lens. That's part of it. That's going to get me kind of the subtotal. And I'm going to add on here 8% or 8 hundredths of that total purchase. Oh, if I were to look at this, I notice there's some distribution. So I'm still using all those steps we talked about. Keywords, no backwards words, but there were some implied words this time. When I talk about 8% of something, this is pretty critical. You might want to write that somewhere. When I'm finding percent of, I'm really multiplying. There is a distribution now. I'm going to want to take this 8 hundredths times everything in parentheses. Well, if I were to rewrite this, that's W plus 120. That's still happening. And I'm going to add whatever I get from this distribution. Well, 8 hundredths times W will get me 8 hundredths W. You might want to put the 1 in the quantity here, showing that that's 1W. That might be a good idea. And if you know 8 times 12 is 96, so I'm going to get 960 when I multiply 8 times 120. So I'll write that out real quick, 960. And I hope you remember decimal bank. Decimal bank would say, how many places over would that decimal land? Well, it looks like 2 places. So this is the same as saying 9 and 60 hundredths, or 9 and 6 tenths maybe. And this is being added. Oh, this comes from my tax. So this portion's the tax. This portion's the total of just the camera and the lens before tax. And I'm really close. But do you notice something? Is there anything more to be done in parentheses? Do we need those grouping symbols anymore? The answer would be no. In fact, those could go away. And if you do that, you might notice that there are some like terms. I noticed that I have 1 whole W plus 8 hundredths W. I could combine those and get 1 and 8 hundredths W. And then I have this 120 plus 9.6 or 9 and 60 hundredths, depending on how you look at it. Well, if you line up your decimals, don't forget to do that, because I see that that's kind of a scary matter for some of us lately. The 120 has a decimal at the back. Oh, looks like I'm going to get 129 and 6 tenths. This isn't too bad. In fact, there's nothing more that can combine. And I probably should have used maybe 2 symbols to show you the constants go together, a different kind of code. Well, the variables are first. Looks like I'm in simplest form. There are no other like terms. I want to talk about how much this costs altogether. I think I need to call this dollars. If you want to give me an awesome math and focus sentence, higher level thinking, of course, would say, Freddie paid a total of 1 and 8 tenths W plus 129 and 6 tenths, altogether dollars, right? And make sure you're showing that grouping symbol somehow for me. All right. These are definitely challenging. My goal for you is that you get a lot of experience with these, because we're going to see them again in equations. So whatever you don't have done today, you are taking home to finish for homework. I suspect that some of these will be really tough, and you're going to come in with some questions for me when I see you next. So keep plugging away. Try to follow those steps. Try to use that visual approach like they suggested, because I think it's going to help us out in the long run. Again, friendly reminder, on page 2 and page 3, when you can diagram, model, or use a table, do diagram, model, or use a table.